So just before we start, I have a little announce to do. We are running a survey that is not only Smalltalk specific, and this is for Java, C, Ada, all these kinds of things, on what are the problems that the people are facing when they integrate a change. So this means that you have your project, one guy modify something. So if you are in this situation, and I guess that most people are in this situation, we did this survey. So this is bit.ly and 14z.c.a.m.y, and we would really need people to fill up the survey. So this is really what are the tools, what are you missing when you integrate a change to take decision and things like that. So this is for a PhD student in our group. So
I feel it.
you feel it?
Yeah, I think so.
Good, Alex. Good. Okay, so we will start this session with two presentations. The first one for Alex on Roassal. This is a scripting engine. And then after there will be a redike from Georg. Okay? So.
Okay.
Do we have
Start
another
now.
I don't know where.
Hi, my name is Alexandre Bergel, and I'm going to show you what we have done with Roassal over the last year. So, me and the students are from the University of Chile, and Object Profile is kind of engineering facade of what we've been doing so far. Okay, so what is Roassal? So the vision behind Roassal is really to be the ultimate solution for data visualization in Smalltalk. And so this is, challenging, and we're not there yet, but this is really the vision we have. And at some point, if you have data that you want to show on the screen somehow, and Roassal should be around. And if not, then send us email, and we have to make sure that Roassal fits your need. And yeah, so something interesting is over the time we've seen people using, using Roassal in a way that we didn't really plan to. For example, some people are doing some animations, and even though Roassal is not really meant to do some animations, it provides some interesting facilities for that. Also, data navigation, this is something often that comes with the need of visualizing. You have a lot of data, you are visualizing them, and you want to navigate through those things. There are different options you can do, like searching, focusing on zooming in, zooming out, and browsing and UI building. And so the nice thing is Roassal, since it's multi-platform, then by doing a UI in Roassal, then UI will work exactly the same on different platforms. And yeah. So some screenshot of Roassal. So Roassal works and is mainly developed on Faro. So the mainstream is done in Faro. So here this is a bit of what can be done in using graffiti. It's going to be demonstrated later. So this is about drawing charts, and we can do some space invader things. And so this is in Faro. Then we can then we have an automatic way to export the code from Faro to VisualWorks. So here this is a screenshot of APAO, which is a code coverage tool to analyze the test coverage of application in VisualWorks. So we're currently working on having Roassal works on Visual Edge Smalltalk. It's currently work in progress, but it's getting there. And so more recently we've been working on having Roassal on Amber. Still fresh, early work. But you can draw some boxes, you can drag and drop those boxes, you can click on them and then things like that. We are slowly moving toward. But the idea is is really to have one software that runs bit by bit on all different platforms. It's quite challenging, but we are we're getting there at some point. Okay, so the very Roassal in a nutshell. So here this is a piece of code. The first line here I create a view, instance of the class arrow view, and here I create an element. An element looks like a point in a vectorial setting. So this is just a point on the screen. And then I can add a shape to this element. And I can say like here I want a green box and with a size 50 by 40. And then I can add element plus shape, and then I add this shape to this element. And then I add element to the view. And then I have something like this. Then if I want like, to make the box drawable and add some actions, then I can, so here I have the same thing. Here I have this arrow bars at where I say element at draggable, and now the green square is draggable. And then I can, if I want to do something when I do right click, then I can simply add menu activable items beep, and here the actions. When I right click and I say beep, then to beep. And okay, so the thing about the shapes can be composed. So here I have like, okay, so here I have the second element where I create, instead of a new element, and then I add a border. It's going to be blue with a thick of 6 pixels, and then here I have the label, font size 40 and Eloise Hook, and then I can do some translation here. I have the 2 elements in the view, and then I have something like that. And many people have been using Roassal to visualize code. So here, like a naive way to visualize code. So here I have like the element again, and here I have like the green box, where I say that, where if I want to associate this green box to the class object, then I would say, oh, this green box should have a particular size that reflects some of the things of the class object. I say like the width will be the number of variables defined in the class object. And the height reflects the number of methods defined in the class object. And then I give that to the shape arrow box. And then on the pop-up I say, if you put the mouse above this element here, I will have object that would that be like this. When I put the mouse here, then I will have pop-up saying object. And now if I want to have the second element, so, let's say the arrow shape class that belongs to Roassal, where I say, exactly the same piece of code here, where I say that the size of arrow box reflect, some of the metrics of the class arrow shape. And here again I say arrow pop-up. So the thing is, so basically you will do exactly the same thing in using processing, for example, or using D3. This is quite popular, or using Athens, or Cairo. This is, exactly what you will do if you want, like, to pronounce size, boxes that reflect something of your code. But the very nice things about Roassal, so really one of the key things is that I can just define one shape, where I say this is a green box, and here I provide a metric, a block, that will be evaluated against an object, against the element that is behind that shape. And this is something that is seen in Roassal and almost nowhere else. So in that case, so here I have a reusable shape, where the shape here, the width will be computed by sending the message number of variables to the model that is behind the element. The element is the graphical thing that you see here. And the model is an object, could be whatever object, behind the element. It means that here I define one shape, and then I can define one element, where I say this element is on the object class object, and then I say this shape here. And then I say this interaction, which is pop up here. And then also I define a second element where I have the same shape can be added, and this one, the arrow element, are on the different class. So the nice thing here is that the interaction and the shapes are reusable. And this is something that you don't have that with processing for default, something that you don't have with, with other graphical libraries. So the thing is that there is a connection, there is a strong dependency between the visualization toward the domain model. That will be yours, your classes, your object. And yeah, so this is again the same piece of code as before, but except there is less line of code, and here I have something that can be reused. Of course, we have some caching that says, that remember the value of those metrics here. So this is really something that is really key to Roassal. So among all the different graphic frameworks you might have, so this point is really key. And then there is many things that comes around. For example, like here, this is a radial tree layout, and that use some basic curves. So it's something that has been done by Mathieu Duc at Hermod. So we have a paper on at a workshop at the UST that describes different layout that he has been working on. So here, this is a layout where, at the center here I have the class collections, and all the things are the subclass of the class collection, and here, all the subclasses of the subclasses, all the things. And then, you have this nice, this nice visualization where we have all these curves, and yeah, we like curves very much. So yeah.
So this is based on that?
Yeah. So this is based on that things. Yeah. So here you have anti-aliasing and yeah. So basically use items on top of Lego. And so here this is a different layout. This is the some new tree layout that do some compact things, or I don't know. Everything is described in the paper, and yeah. So this Mathieu did a really excellent job. So we have like 4 or 5 new layouts. So here, this one now is the spring layout, so the force-based layout, which is actually called spring layout. So the idea is that each node is a magnet, and the magnet repels each other. But then you have the spring, the link between those magnets that attract them. So then, if you leave those graphs, then you have some, something that's somehow emerge on its own, and then you have something which is quite appealing visually. So here, this is like something we have the gravity. So this is, nice things that's what you did. So we have this gravity, that put everything up. And yeah, so now I would like to show, how come the demo time. I didn't want to do demo of everything. I would just show you like some pieces that we have done. Okay, so this is maybe like my personal own work that I've been working on, which is the smart browser, something I call smart browser. And so this is kind of new programming framework based on the top of Roassal. So here I have, big squares are packages, inside are classes, and then those are the packages. Here I have the name of the packages. So here this is the class. When I put the mouse above the class, then I have the name and some matrix. And the thing is, here I can navigate the code. Let's say that I want to find.
What is this square?
Yeah, this square. I will show that later. So this square will show the code graph of the method I'm defining. So let's say I want to find, let's say the class abstract canvas. So this is something that works well when I have large screen. So in that case, it's not really the case, but so. And so here I've selected the class abstract canvas. So here this is this one, and then I can click on this one, and then I'm navigating within and updating this browser. So the idea is like to have to record all to have a nice overview of the systems while recording all the different action I'm doing, such as the classes I'm browsing here. Because if I do that, then I see that all the classes I'm browsing. So here I have the yellow. The yellow means this is the class that I've checked. So you see here this class, the first one that I pressed on. Now at the very beginning it was intense, it was yellow intense. Now it's fading out a bit. So here I will, until it's it is becoming like very almost white. So there is a history of temps. So the idea is that in yellow, this is what we have done recently. Okay, so as I said, this is a really small screen, but yeah, let's say that I'm defining, maybe if I do that, foo. I have a method foo. So here I have this small square that shows the method foo. And now here I want to define bar. And then here I have this foo, and the foo so called the bar. And then here I have, the link that appears. And again, here you have this yellow convention that says, what are the methods that I've recently modified. So this is, just pure experimentation we are doing on what would be the, nice way to navigate and program. So the thing is, like in Eclipse, people are spending all their time switching files and looking for doing some text matching. you know. And in Faro, we are constantly opening and closing code browser. So this is something, those problems we want to address using the smart browser. PhD is going to work on that very soon. So yeah.
Alex, it would be good if you could contact David to get back the often leaves algorithm.
Yeah, could be. Yeah. I mean, he's around, but I don't
I know.
got the chance to talk to him that much. But yeah. I mean, this is just this is not really the end goal. I mean, the goal is to really have something where we can do experimentation, and the other needs indeed would be something. Even though, like in that case, the idea is just to have one browser, one code browser opening. Okay, so that was for smart browser. Then I can show you like Visual ID. This is at that time. This is the result of one of the my lecture I did the last semester, and the idea is that the idea is to be able to generate some icons automatically. So, on any computers and on desktop, you have some icons, on the desktop that say, oh, here I have the folder, like HSUC, and then you have an icon that shows this is a folder. Or if you have a PDF file, then you have an icon that shows, oh, here this is a PDF file. So the idea of Visual ID is to take this metaphor and to put that into to visualize data. And the idea is that how to generate some icons for some data. And then if the two icons look similar, then they are kind of related somehow. So this is some early work we've been working on, but we have everything with the code, that is under an IT license, and yeah. So the idea is how to generate automatically some icons for any piece of data that matters to you. And
so the idea is that the trick in this visual IDs is that they should always somehow be the same, is similar to the one that are related to. So
yeah, exactly. So so here you have all these elements that somehow visually are the same, so therefore that are very, very close. Maybe those are those classes with exactly the same amount of methods or the same amount of attributes. Something that we are working on. So here we see that there are some differences because here something is missing, and here you have this small circle. So it means that this class and those ones are really similar but not equal against some metric that we provide. And also, like, we've been working on the spline. So one of the students, Hernan, has been working on the spline. So the idea is that so here I have three elements. The three elements are druggable, and here I give initialize position, and here I say that I define an edge from elements 1 to element 3, and here I add to this edge the shape, which is a B-spline line, red color, and then we say that there is a custom point, the element 2. So I use that, and I have this small visualization here, where I have this point, and it's kind of attract the B-spline. I mean, you might say, oh well, I mean, all the vectorial graphic tools, they do this kind of thing, right? Where you can, define the shape in a very fancy way. But this is really a small element that we use to build something a bit more complex, such as the hierarchical bundle edges, where you have this kind of fancy, kind of organic-like visualizations, where instead of having all the edges straight, they follow some kind of path, in order to to that visuality we see something else. And yeah, so I mean, this is a visualization that's been done using Moose platform. So those are class hierarchies, and at the bottom those are dependencies between the classes. And so it's currently a bit slow, but you can drag and drop some elements, and see that the things are adjusting themselves. And I mean, it has been done by some students.
You were calculating all the geometry every frame.
Sorry?
I think it's slow because you calculated.
Exactly. No, I mean, I know why it's slow. It's not fast at all, because there is some complex algorithm to draw to draw, and this line actually is made of small lines here, and then there is some, some complex manipulation is done. Probably there is beta caching that can be done. I mean, on JavaScript, I've seen something a bit similar where you could, can have some snappy and fast things. So probably we should be able to do at least the same. So here in that case, this is, each line has a transparency, and when you have a lot of lines that goes in the same direction, then it's becoming like intense. And so this line works with different layouts. So here this is the radial tree layout. Now if I have the tree layouts here, then I have this, something like that. Instead of having all the lines straight, then that follows on some kind of line. Okay, and that's something I forgot to show. This one here. And so here, this one is a very small example where here I have 5 boxes, and when I put the mouse above some of the boxes, some edges appears. I mean, it doesn't look that fancy, but this is really recurrent problems that since we've been working on Mondrian like 6 years ago. I mean, that has been a constant thing people were asking all the times. I mean, I have too many edges in my visualization. How I can, just show the one that I'm currently focusing on. So the nice thing is here we have provided the necessary infrastructure to define such a thing in a really easy way. So here we have, 5 elements that are described in the dictionary here, where I say layer 1 goes, there is an arrow from layer 1 to layer 2, 3, and 5, is what happens here. And we have these dynamic edges for all, and using the red line using an arrow, and here we have all the nodes that defines the 5 there. I mean, this is really, small amount of code to define something that, people have been asking for since a long time. And something else I want to show you, like, so the mini map. So the mini map here, this is, a plain visualization that shows some classes in the system, but it doesn't matter what it shows. So the thing is, the visualization is big, so you can do some zoom out, or zoom in. But the nice thing is that if you press the key M, here you have this mini map, where you can do some drawing here, you can zoom in here. And yeah, I think this is what I'll show you. Okay. Okay, so there is really, many things that I haven't shown to you, like about the scalability. Visualizations, it's easy when you have a few nodes, when you have few elements. But we've worked a lot on scalability. So now, we provided the necessary infrastructure where we have some predefined way to caches the visualizations. And now it goes really smoothly with over 500,000 nodes on the screen. And then you can just, scrolling is really smooth. So this is something we're currently working on. The scalability is really, really strong issue. Currently we have some, some nice proposal, but we have, to see a bit how it goes. So we have now exporters in PNG, SVG. Also we have HTML, the things. SVG is quite important because this is the key to have, to put pictures actually in paper. So we use that a lot, because you can convert the SVG into PDF in a really easy way. So yeah, so you have also zooming in and out. So I mean that we have a kind of camera. So you have the 2D surface, and then you have a camera that moves. When I zoom in, the camera goes down. When I zoom out, the camera goes up. And we have a lot of testing. So this is, maybe more interesting from an engineering point of view, but this is really key to us because since we are moving, exporting Roassal to different platforms, we need to make sure that we are not breaking some invariant of the applications. We have really many layouts, and it's really easy to create a new layout. And also, we use Cairo, and I think Cairo is also used on, thanks to the work of Chris. We use Cairo in VisualWorks. And also, more recently, the has been working on the integration with GraphViz. GraphViz, for some people that may know, is some Unix tools, that's super optimized, super fast to do a layout of really large nodes, or really large graphs, thousands and thousands of nodes, and it works quite well. So we, using OH process, we talk to it directly, and then we can, use graphics to really do some big layout. I think that takes time if you do it in plain Roassal. Okay, so here this is a bit the stack that we're currently building. So here at the center we have Roassal. So here you have Roassal, and the Roassal works on different platforms. We have a way to export in a very automatic way things, and that works pretty well so far. And then on top of Roassal we have builders. So you can compare like Roassal as an assembly language, and then you can compare those things as some programming languages where we generate some things that from the low level. So here we have Mondrian. Some of the visualization have used Mondrian. So Mondrian is a builder, domain-specific language to easily build a polymetric view. In 5 lines of output, you have some nice, natural representation of your data. And here we have graffiti that's going to be demonstrated by Daniel. Daniel, where is it, Daniel? Move the hand, Daniel. This is Daniel. And he's going to present that at the Show Us Your Project. And this is about draw some graphs, charting. And the sunburst is going to be shown by Milton. Where is Milton? Milton, move your hand. This is Milton. He's going to show, to show a video of sunburst. This is really cool, really cool. And then we have plenty of things. I've seen people like working on some builders for visualizing aspect, IOP programming. And the nice thing, the really nice thing is that those builders can be combined. It means that we can use graffiti within Mondrian, and that goes perfectly well. Okay, so now just just to finish up, like some screenshots. This is what Milton is going to talk about. Some really, really nice things. Then there is Alejandro that's been working on where is Alejandro? Move your hand, Alejandro. Well, this is Alejandro. Has been working on visualizing the executions and the memory consumption of some of the applications. So this is what we have done. So this is test coverage. And here this is the, so the red part are the part of your code that are not covered by your test. And you can right click on some of this red square and write some tests for those particular method and run the test again, and then you have less red. That's the idea. So with Kai we've been working on some performances monitoring. So here this is the call graph, and the red, the big fat yellow methods. So those are the methods. This is the method that takes a lot of times, executed many times, and they are yellow. It means that they can introduce a cache here in a very easy way. We have paper that describe all that. And then this is what, more specifically, what Alejandro has been working on. So those are the classes of your systems, and inside you have some inner boxes, and those inner boxes are group of objects somehow that can be refactored out. So those are the equivalent objects. It means that when you have like a big square like this, you can introduce a singleton pattern or some 5-way patterns, and then you reduce by a certain factor the amount of objects that have been created. Still something that has been we've been working on, still early work. Also there is Denis Shank, who is not here today, has been working on tree map of some data. So here, kind of fancy things. So I've been working on that for to visualize different things, such as the component, nesting component in architectures. And so those are the files. So this is to run the file system. The big square is the file that takes the most space. That's something we've been working on. We try to show that at the Show Us Your Project, something with Roassal 3D. So Roassal 3D is super cool, but now we have some fast.
This is hyper cool.
This is hyper. This one is really hyper cool. I mean, it's still early work. So next year, something we will probably have something to show at the world on that topic. So yes, so there is some documentation about Roassal in this new book. Super cool book. So we have a lot of them. 25 euro each.
The new books arrive.
And the books just arrived just in time, right? Just in time. Okay, so this is what I wanted to tell you. So thank you guys.